Sorry, Instagram just kicked me away. Let's try this again. Let's try this again. Hello, hello. Let's wait for... Yeah, so I was talking to my sister. We were having our Q&A, and then Instagram decided to shut me down. So we're gonna wait for my sister again. We were talking about genes and DNA. She was explaining what DNA was, because ultimately what we're gonna talk about is epigenetics. So I'm really sorry, but Instagram just cut me off. So I just logged back in, and I'm gonna wait for my sister to come back. So the subject today is epigenetics. So if you want to ask any questions, type them in the comment below, and I'll ask her whenever she's back. She was talking to us about DNA. So you know, DNA, we are all, our bodies are chemistry, molecules. So DNA is what makes our bodies, all right? There she is, she's gonna join us. So she was explaining to us how this exactly worked. Let me just accept with her proper vocabulary what exactly DNA is. Hi, Carmen.
Okay, now it's better. Now I got it.
Yeah, Instagram just cut me off.
Yeah, so. Exactly. So that's okay.
Okay, so DNA. DNA.
So the DNA, we were saying, is the material we inherit, and it's stored as chemicals, bases that we call, and basically ACGT. So when we see that stretch of ACGT, we have 3 billions of ACGT throughout all the human genome. So, you know, it's a big chunk, but it's all condensed into the cells. Each cell has DNA.
Got it. Okay, cool. And as I was reading about epigenetics, I saw something about genotype and phenotype.
Right.
That I remember. I saw that when I was back in high school, but I'm sure no one remembers what that is. Could you explain?
All right. Genotype is exactly what those 4 letters and how that DNA is read. And phenotype is what we see the expression on us. So your phenotype, we're sisters, but our phenotype is different, although our genetic materials are could be very similar, but your colorads are different, right? Let's see. Yes, I think that. Etc. etc.
So basically, we could say that
what we see is the phenotype. It's like when you have a musical composition. For those of you musicians out there, when you see a pentagram, that would be your DNA. But if that notes are played by a kid orchestra, it's very different that if you listen it played by the Philharmonic.
Perfect. So in other words, the genotype it's inside, the phenotype it's outside.
It's what we see.
What we see. Perfect. Right. So now let's dive into the subject, epigenetics. How can we define epigenetics? What is it?
So this is an interesting term. So basically, it's the way we can change. So if we just look semantically, epigenetics is over the genes, over genetics.
Okay.
So it's processes by which we can change the expression of the genes. So we know the genes, they codify or they produce proteins at the end, but the fact that they do get to produce the proteins or not can be changed by these epigenetic mechanisms.
Okay, so
can be altered.
This means that we can alter our phenotype.
Correct.
Based on certain things that we do or we don't.
That we do or we don't do. Correctly.
Got it. Perfect. Cool. Right. So guys, just remember, for those who are watching live, if you have questions, put them in the comments and we'll try to get back to you as soon as we can. Okay, so now linking this subject, epigenetics, with what I actually do with this fitness.
Right.
Can exercise alone induce any epigenetic changes?
Okay, that's a very good question. First of all, remember when we talked about 2 weeks ago, the people that were not there, we were talking about the opposite phenomenon. We were talking on how the genes or our genetic makeup could impact our fitness and exercise. Now we're going to see how what you do can change our epigenetic setup. And yes, exercise can influence our genetic expression. Okay, there are 3 basic epigenetic mechanisms. I don't want to go into this, but just to explain a little bit. One is called methylation. Doesn't matter what it is. The other one, it's called histone modification. So I was telling you that the DNA is wrapped around proteins. So you can see if the DNA is very condensed, it's not going to be producing any protein. I mean, it's not going to be red. But if it's relaxed, it could be red and it could produce something. So that's another epigenetic modifications. And the other ones are also other molecules that do not codify RNA, but they can influence. Why am I giving these explanations? Because it has been shown that exercise can influence these mechanisms. It can influence, for example, endurance exercise can produce changes like methylation that will improve our muscle regeneration.
Wow. Okay, cool.
Low intensity endurance exercise can suppress inflammation.
Wow, that's nice.
Also through epigenetic changes. So, I mean, I give you an example, and this is important to note because it has been shown that when you do a 6-month endurance training, there is a change on how insulin regulates the glucose uptake in the muscle.
Okay.
So actually, your risk of type 2 diabetes will decrease.
Yay.
Okay. And through other mechanisms, this mRNA that I was talking to you about that really do not codify, but they're there and they can induce changes. It has been shown also that subjects after a 12-week training period improve their maximum oxygen intake and they improve their insulin sensitivity. So that's very important. But most strikingly, all these people, they've been training, and let's say they have an accident. And they're 7 days resting in bed. All the muscle regeneration that occurred in 7 days is lost.
No.
So you should keep active the whole time. Okay. So whatever you gain from training just remains in your system.
Okay, wow. Okay, that's striking.
So, I mean, when you see the people that are hospitalized in intensive care, you see they lose a lot of weight.
Yes.
They lose muscle mass. So that's also due to epigenetic mechanisms. And of course, lack of fuel intake. That's the other thing. So you were asking about exercise alone, but actually you need also to have a balanced diet.
So are there like epigenetic diets or something like that?
Okay. Let's see, they're trying to get into that. I don't think the studies are gone far enough to be able to cast an epigenetic diet. But I can tell you, for example, that we were talking about methylation process. For the methylation process, we need methionine. That's another chemical. And there are elements and nutrients that are improve methionine synthesis, such as folic acid, vitamin B12. So if you are not ingesting those components, then this epigenetic network is not functioning either. So you have to have a balance between exercise and proper diet. Another striking thing, you know, we have our Western diet here in the United States and Canada that is full of hamburgers,
hot dogs.
And then we have the Mediterranean diet of more European, which is more vegetables,
Fruits,
fruit, good
olive oil,
healthy fats,
mm-hmm.
Fish,
Yeah.
etc. Right? So even pregnant women that eat Western diet, there have been that the epigenetics mechanism have some impact in their babies before they're born. So, you know, you have to be very conscious about what you eat while you're pregnant and when you're not. And also, in contrast, Mediterranean diet has been shown to be beneficial for the for cardiovascular health.
Yeah, yeah.
So that diminishes the person's cardiovascular risk. So, and this is all through, you know, one explanation is through epigenetics mechanisms.
Okay. So bottom line actually is, yes, you could have some impact of the expression of your genes through exercise and through diet, but actually what you want is to do both, right? One or the other.
It's the perfect combination, right? And I remember when I was here 2 weeks ago, you asked me where if I'm obese or I have a genetic predisposition to a disease, can I change that? Or can I not change that? And there have been studies like in healthy subjects, but with family history of type 2 diabetes and obesity, that when they do endurance exercise, since their insulin sensitivity is better, there is, and you do a biopsy on them, you see that the expression of a receptor is not a receptor, it's a transporter called GLUC4 is up, so they handle a lot better the glucose uptake in the muscle.
Okay.
So they can diminish their risk for type 2 diabetes, although it's in their genes and although it's running in the family.
So said with different words, so I'm just going to rephrase, okay? If I have high risk of type 2 diabetes because my family, there is a bunch of diabetics in my family.
Correct.
Then instead of saying, whatever, I'm doomed, I'm going to have diabetes, I have the possibility to change that expression of that genetic makeup that might might make me prone to have diabetes too.
Correct.
So instead of just saying, whatever, I'm doomed, I'm done, you
can have an impact on your genetic expression. You're not going to change your DNA composition, but you can have an impact of what is read out of that DNA. I mean, that doesn't work. Again, you know, last week I was telling you there are mutations or there are things that when the genome goes wrong, it goes wrong, and we cannot change. But definitely, we can change a lot having a healthy life.
So we can say we can affect our genes through our lifestyle.
Correct. That's a correct statement.
Nice. And question for you: are there epigenetic tests in the market?
Right. So I was researching that, and there are a few. Most of them are related to cancer, because there are epigenetic mechanisms that can protect for cancer, and there are others that can increase cancer risks, depending on which genes they are going to be turning on and off. And that's the thing, we don't know enough about it, what and when turns on or off the genes. So that's why having a definite test is a little bit complicated right now. I know there are epigenetic tests that are trying to look into health issues and into aging. There are tests that tells you if you want to know your age or your mental, if you're aging, you know, mentally, we can tell you. And the truth is that there are tests out there, but I think the data is still preliminary to go on that.
Okay, okay, but it's in the future, right? It's in
Yes,
our.
the research is being done, and I think we're gonna get into that not only in the impact of genes in all areas of pathology and health, but also the impact of these epigenetic changes in pathology and in.
So you mentioned cancer.
Yeah.
Are there any other diseases where you can see this epigenetic test having a great impact?
Well, obesity, type 2 diabetes, inflammation, cardiovascular diseases.
I don't know why I'm thinking about Alzheimer's. Is that a possibility too or not?
It
I'm
is a
sorry.
possibility. It
Okay.
is a possibility. There is no research. There is not enough research done on
Okay.
it, but it could be a possibility because one of the mechanisms of Alzheimer's is the loss of neuronal circuits, and you really don't know why they're being.
What they're being damaged.
Damaged. So
Yeah.
I mean,
Okay.
why they're being damaged, but we know
Okay.
they're being damaged.
Okay, perfect. Okay, cool. So guys, any questions, type them now in the comments. So to wrap it up, I'm gonna repeat what I said before because I think it's a really nice way to summarize what we have been talking about tonight, which is that we have the possibility to affect or to change or to have an impact on the expression of our genes through our lifestyle habits, correct?
Correct.
So guys, if you feel frustrated because maybe there is a lot of type 2 diabetes in your family, obesity and such, know that there is a possibility to actually switch this up so that through your lifestyle, through healthy changes, you can actually maybe lower the risk of having these diseases that run in your family.
Right.
Yes?
And we have to remember too that this has to be a continuous thing. As we said before, I mean, you could do all this training, but once you stop, then all the remodeling that went through, we can lose it. So ideally, you have to, whatever changes you introduce, that you see that it's good for you, or if you go to your doctor and say, okay, you're doing better, you're getting better, it's important to maintain it.
Yeah. So actually, because that's a part of lifestyle, right? Lifestyle means it's for life. It's not that you're gonna do it 3 months and then summer is over and you're gonna go back to your old lifestyle.
Yeah, exactly.
Okay, cool.
Okay,
perfect.
I mean, for these benefits to maintain in your healthy life, you have to really change the lifestyle aspect.
Exactly. You have to have new healthy habits that are gonna be there long term.
Correct.
Perfect. Love it. All right. So I don't think we have any questions. However, this video is going to remain here on my Instagram account. You can watch it later if you joined and we had already begun. Just watch it from the top later on. I'm going to put it on my feed. And if not, I'm just going to say big thanks to my beautiful sister, Carmen. Muchas gracias.
Thank you. Gracias.
Next week, guys, we're going to talk about sleep hygiene, which is a subject that I'm very, 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 very interested about because lately I've read a lot about sleep, and it's like you have to sleep, eat, and exercise. It's not only about what you eat and how much you move throughout the day. It's also about how much you sleep. And maybe, Carmen, we can do another one about sleep and genetics. I don't know. I'm just throwing it out there. I don't know.
No problem.
Thank you so much. Thank you. Gracias. Te quiero mucho.
Bye.
Good luck with election night.
Yes. Now I'm going to go straight to the TV screen to see what's going on.
Yeah. Good luck there.
All right. Thank
you.
you.
United States, guys. So wish her luck. Bye.